Hello, everyone. My name is Darwin Sonoy, and I work in GitLab's field CTO office. Wanted to share with you some details about running automotive stacks on STEM robots. I also want to acknowledge the help of my great collaborator, James Moverly. He's helped me a lot with a lot of this. I've been working with STEM robots for about 2 or 3 years, but James really helps bring the depths to light whenever I need that kind of information. So I've been wondering for a long time if we can run automotive stacks on a stand-in STEM robot, something that's cheaper but can show us how things work and give us a more palpable real-world experience of that. I mean, if you work with robotic systems, who hasn't just loved to make something happen in the real world through software? So I'm hoping that being able to have this platform available would help a lot of people kind of get the concepts. So we'll talk a little bit about the SOAFEE architecture, which is the one that I'm targeting with this. This is the general architecture, very high level, low granularity, just looking at hardware and then the open standards for SOAFEE, and then on top of that, applications that run within the vehicle. I want to show you how this translates to the robotic implementation that I have here. So first of all, at the hardware level, the robot that we'll be looking at, the Petoi Bittle, runs the Arduino Uno. So that's what actually drives the hardware, responds to sensors, and makes the entire system work. Now, on top of this, we need a more capable system because I'm going for the Kubernetes architecture. So in order to implement Kubernetes, you can already with the Petoi Bittle system, you can mate it with a Raspberry Pi and get a control plane above the level of the Arduino. So this is what I've done. I've used a Raspberry Pi 5. The Orange Pi 2 is the only one with enough memory that's got a much smaller form factor without ports. And so I have tested the software stack, but have not done the hardware interfacing on that. But that might also provide a way forward that is much kinder to this really cool looking form factor. That's the hardware control plane level. And there's a GPIO serial connection between these two. I got this working a couple years ago. But then on top of that, we need to deploy Kubernetes. So we'll be deploying the K3S Kubernetes distribution. And then in order to show that this can all work together, I've created a Bittle control pod, which then allows us the control connection all the way from a container right down to the hardware to see the hardware respond. Now, being a DevOps person working for GitLab, I also wanted to show how the DevOps platform can add value. So using GitLab is where I've done the software development, but also interestingly, GitLab has something called Agent K or GitLab Agent for Kubernetes. And that capability allows us to manage Kubernetes clusters. And so what I'll also be showing you is actually deploying this Bittle control pod using Agent K, which also demonstrates that obviously anything at that application layer could be managed by that Agent K connection. Well, it's not part of the demo. We can also put the GitLab runner on that hardware level at the Raspberry Pi level and do much more fundamental maintenance. SOAFEE also calls for running a separate cluster for kind of connectivity and updates from the actual car control cluster. So you could potentially upgrade one cluster from the other cluster. And so this implementation puts this all together. I have the first, what GitLab calls MVC, or minimum viable change, working, released it as what I call 00.6. And you can find that at sdv.bot. So now we'll dive into a tour of the hardware itself. So let's take a look at our hardware platform. This is the original back, doesn't fit so well anymore. I'm going to remove this addition for a minute. So this is the Arduino Uno, the original platform. And in order to interface a Pi, we had to take this, solder this 2x5 connector on here. Once that's soldered on, then the standard 40-pin connector of a Pi, the first 10 pins fit right in there. And the cool thing is it powers the actual Pi. And then the Pi, in this case, the Pi provides wireless, Bluetooth, all kinds of additional capabilities. And so that's the second layer of that hardware that we talked about. And then we'll be taking a look at software here just in a minute. Just on our diagram here, I want to show you that This is the bottom level that we looked at with the whiteboard, and then the next level up. So those are the two parts of the architecture we just looked at with the hardware. So now let's dive into a little bit about the software and getting the whole thing to work together. All right, we've got the bot powered on, and now I'm going to show you some additional setup options so you can see that we're adding certain layers. These are the setup instructions that are at sdv.bot. We did this first step for you because it's just a lot of boring procedures for setting up the hardware as well as updating to the latest operating system. You can look through this code to see exactly what it's doing. But we're going to do the deploy Kubernetes piece. And so we'll go over to our command prompt and we'll log in. For those of you who've worked with our Raspberry Pi imager, you can set all of your wireless details in the imager, and it actually will then boot the Raspberry Pi directly to your wireless network, and you can SSH in without having to fuss with attaching physical keyboard, mouse, and monitor. Now what we're going to do is run this script. It's designed to just be run directly from the web. It downloads and runs it. It's going to actually take the latest release of K3S. If you run into problems because it's taking the latest, you can always freeze it to the version that you see here on your screen. It's also documented in the release notes what version was tested for this software. K3S will take a little bit to set up, and then I put a 2-minute wait in the script because some folks get overeager and start trying to do more things to the cluster before it's time. What I'm going to quickly do here is just cancel out of that, and we'll just give it a bit of a watch. kubectl will be here already for us. And we'll just look at all pods on the system so we can see the system level pods. So you can see we still have a lot of containers being created in order to facilitate all the operations of the cluster. As these get completed, the next thing we'll do is deploy a pod onto the system that helps us manage the actual bot. So what we're doing right now is this K3S deployment. And then the next step we'll take is we're going to go into GitLab and integrate the agent. So in GitLab, we get some code and we'll use that on the cluster to install the agent. So those are the next pieces we're going to go through here. See how our cluster is doing. Got running. The metrics server isn't absolutely critical for us to continue. Got a couple more bits of utilityware installing. So I think we'll be okay now to get started with the registration. So there is instructions for just manually putting this pod on. So this GitLab piece is optional. And if you're going to do it yourself, there's additional instructions right down here in this appendix, but I'm going to go ahead and do it through GitLab. So we're going to get into our operate Kubernetes clusters. We're going to connect a cluster, and I already have a pre-configured agent file that works in this repository. The instructions show you how to change this file a little bit because you'll have to move the repository in order to have the permissions to create a cluster connection. So all that's in the documentation. This is a one-time screen, so if you close this window, you won't see this token again. So you have to make sure that you either leave it open or that you copy the information somewhere else if you think you'll need it. Now I'm on the Raspberry Pi on the robot. Part of the last deployment was it also installed Helm for me. So we should be able to use this Helm command directly. Okay, so it's successfully updated. Oh, no, it didn't quite get it right here. So what we're going to have to do is go back to the repository. There is a export of the kube config file. So for Helm to understand where we're at, we have to give it this information, bring our registration command back, and now we got better results. Now, the way you can tell if this worked or not is we go back to GitLab and we go to our operate clusters, and we should now have a green connected. Before we ran the code in the cluster, it said not connected and had a gray icon. So that they were in good shape there. Okay, so let's double check where we're at with our cluster. By the way, I will have destroyed this token by the time this video is published. So So here we can see that the Kube system is all ready to go. And then down here, we have our GitLab agent. It starts 2 copies so that the agent can update itself with 0 downtime. So our agent's there now. So if we look back at our list here, we have gotten to the point where we have got the agent on the system. Now we're going to run a job that will use the agent connection to deploy the Bittle control pod. Now we're going to deploy here. So what I'm going to do is go into build pipelines, and I'm going to run a pipeline. And if I wait for a little bit, I get this bit of a form here, and it says deploy Bittle pod. And I'm going to change this to true. And if everything works correctly, it's going to deploy that pod for us. It's actually using straight on Kubernetes commands. You can use Helm or kube control in this case. GitLab agent also supports full pull GitOps. So this is really a push GitOps that we're doing here through that agent connection, but it can also do a full pull and has Flux support. Okay, so we can see that it started creating that container. So now we're going to take a look right directly on the cluster, and we have the same container creating. So now if I go back to our diagram, what is happening is this deployment right here is occurring, and this pod will be live very shortly. So let's take a look. Okay, it's ready now. So I'm going to go back to the instructions in our repository. And in here, it tells me how to test. So first of all, I've got to get inside of that pod. So we exec into it. So I'm back here on the Raspberry Pi. And as soon as I do this, I will be inside the pod. Back on our diagram, I am now inside this pod here. And if everything works correctly, I should have a clear connection all the way through to the Arduino to make it make the robot do something. So if you're watching the robot on the camera, I'm going to go grab the little code snippet here, and we're going to make the robot stand up. This is where every demoer crosses their fingers, holds their breath. There's a little bit of code. You can look through all the code to see how we're getting through to the port so that that can happen. So you can see there that the dog stood up. And once we get our panel back, we will do another behavior to get it to sit. And if everything works right, there we go. Oh, his back fell off. And there's one more that we can give to make him back to his original position. And there we go. Also, you'll notice in the documentation that there's a whole bunch of other commands you can send across this control connection now that it's working. So I hope you've enjoyed this little tour of what we might accomplish with STEM robots and the automotive stack. All of the code can be found at sdv.bot if you want to get started on your own project. Thanks a lot.